Okay, today we're going to be working on a topic that's going to be review for most of you, and that is the coordinate plane. One thing that we need to know about the coordinate plane is that it does contain all of the ordered pairs, and we label those ordered pairs as x and y. Remember that the x-axis is the horizontal axis, and then the y-axis is the vertical axis. The origin, which we label as O, is the point corresponding to the ordered pair 0, 0. Every time we count a number to find a coordinate, we always start at 0, 0, and then for positive x values we count to the right, for negative x values we count to the left, for positive y values we count up, and for negative y values we count down. An ordered pair consists of an x coordinate, those that tell us to go left and right, and then a y coordinate, the ones that tell us to go up and down. These coordinates represent an exact location on the coordinate plane. The coordinate plane is divided up into fourths, which are called quadrants. They're numbered from 1 to 4 using Roman numerals. Starting where the x values and y values are both positive, that's quadrant number 1, and working our way around counterclockwise until we get to the fourth quadrant. Okay, in example 1, the first thing we want to do is describe and sketch all of the ordered pairs x, y such that x is less than or equal to -3. As you think about this, we need x to be less than or equal to -3, so the y value doesn't affect anything. That means we're looking at all of the ordered pairs with an x value less than or equal to -3. To graph this, we're looking at a shaded region to the left of the line at x equals -3, and also the boundary line needs to be a solid line because it's less than or equal to. That means that the line is included in the solution. Any point on that line or to the left of it will make this statement or will be part of this set that we're describing here. Alright, next we want to describe and sketch the values that order pairs x and y such that x is equal to 4. Well, if x is equal to 4, that is a vertical line. It's all the ordered pairs with an x value equal to 4. And as we look at that, that is a vertical line where x is equal to 4. Every point on that vertical line has an x value equal to 4, whether it's 4, 1 or 4, 0 or 4, -85. Now in this one it's a little bit different. We want to sketch the ordered pairs x and y such that the absolute value of y is greater than 2. Now remember, when we talk about absolute value, we're talking about the distance from 0. So we want the y value distances to be greater than 0, to be more than 2 units away from 0. Which means we're talking about all the ordered pairs with y values that have an absolute value greater than 2. This is going to look like the region above +2 and the region below -2. You can see this is a shaded region, and the boundary lines are dashed because this is just a greater than problem. This is not a greater than or equal to. Okay, our next topic is the distance formula. And this is something you're familiar with, although a lot of times people don't like to deal with it because it can get a little messy and it has radicals in it. But the distance formula is this formula: d equals the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared. If you think about it, it's really just the Pythagorean theorem, but already solved for the hypotenuse. Okay, in example 2, we're going to take a minute here to find the distance from -6, 5 to 2, 3. For example number 2, we want to use the distance formula to find the distance between these 2 points. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And so really all we have to do is plug these numbers in. So our first step, remember that this is our x value and an x value, so let's just call that one 1 and that one 2. That means this would be y1 and this would be y2. So plugging these values in, we're going to have the square root of 2 minus negative 6 squared plus 3 minus 5 squared. The rest of this is really simplifying. 2 minus negative 6. Remember that subtracting a negative means that you have 2 plus 6 squared plus, this one we can simplify, 3 minus 5 is going to be negative 2 squared. 2 plus 6 is 8. So now we have 8 squared plus, go ahead and square that, negative 2 times negative 2 is positive 4. Over here that gives us 8 squared is 64 plus 4, which equals the square root of 68. If we want the exact answer, we can simplify this by breaking it up. 4 goes into 68, so we can break it up into the square root of 4 times the square root of 17, which gives us an exact answer of 2 root 17. On the PowerPoint, I've got the approximate answer there. Okay, so you've got your exact answer or the approximate answer on the PowerPoint. That distance is the square root of 68, which is approximately 8.25. Next, for example 3, we want to find out which point is closer to point A. Point P is negative 6, 5. Point Q is 2, 3. And we want to know which one is closer to point A, which is 5, 3. Okay, in example 3, we're supposed to use the distance formula again to find out if P or Q is closer to point A. That means we need to find the distance from P to A and then the distance from Q to A. So first of all, the distance of PA, using the distance formula, again we're just plugging in the numbers. So using A as 0.2, we're going to have 5 minus negative 6 squared plus 3 minus 5 squared. Simplifying this, we know again, subtracting a negative is the same as adding, so now we have 11 squared plus negative 2 squared. Simplify that. 11 squared is 121 plus 4, and that gives us that the distance of PA is the square root of 125. As we look at the distance of QA, we're going to do the same process. Okay, point A, x value is 5 minus 2 squared plus 3 minus 3 squared. So that equals 3 squared plus 0 squared, which equals the square root of 9, and that is 3. We really want to compare the radicals. The square root of 125 is clearly more than the square root of 9, and so which one is closer? Point Q is closer to point A. Now the midpoint formula. If we're given any 2 points, point A, which is x sub 1, y sub 1, and point B, which is x sub 2, y sub 2, the midpoint of that segment AB is going to be the sum of the 2 x values divided by 2, and then the sum of the 2 y values divided by 2. It's really just the average of those 2 x values and the average of the 2 y values, which makes it very easy to figure out. Now we'll take a minute to find the midpoint of the segment that joins 7, negative 12 and 1, 6. Okay, in example 4, we're supposed to find the midpoint or the point that's halfway between these 2 points. So using the midpoint formula, we have the midpoint for the x-coordinate is going to be x1 plus x2 divided by 2, and the y-coordinate will be y sub 1 plus y sub 2, also divided by 2. Again, this is just plugging in values. If we use that as x1 and that as x2, this is y1 and this is y2. We just take 7 plus 1 over 2, and for the y values we have negative 12 plus 6 over 2. Okay, simplifying that, we get 8 over 2, and we get 6 over 2. And then finishing that off, 8 divided by 2 is 4, 6 divided by 2 is 3. So our midpoint, again, the point that's halfway between 7, negative 12 and 1, 6 is the point 4, 3. Okay, check that. As you can see, if you're paying attention, I did something wrong here. Negative 12 plus 6 is negative 6, and then negative 6 divided by 2 gives us negative 3 for our answer. So it should be 4, negative 3. And on the PowerPoint, we'll see that. As we've shown, that midpoint is 4, negative 3. Here's the midpoint formula again. In this example, example 5, we want to show that the diagonals of PQRS bisect each other. And we're given that point P is 1, 2, point Q is the point 4, 4. Eliminate that comma there in front of the first 4. Point R is 5, 9, and point S is the ordered pair 2, 7. After using the midpoint formula, we find out that the midpoint of segment PR is 3, 5.5, and also the midpoint of QS is 3, 5.5, and therefore the diagonals do bisect each other. Okay, here's example 4. It might give us a little bit better idea if we kind of draw a sketch of what this looks like. So point P, just a rough sketch, is the point 1, 2. Point Q is the point 4, 4. Point R is the point 5, 9. And then point S is the point 2, 7. And it doesn't really matter what type of quadrilateral we have. We're just connecting the endpoints to form the diagonal. So we're going to go from P to R, and then from S to Q. So first of all, using P and R, the midpoint for PR is going to be 1 plus 5 over 2, comma, 2 plus 9 over 2. As we simplify that, we get 6 over 2, and we get 11 over 2. That gives us 3 and 11 halves, which would be the same as 3 and 5 1/2. Then going for the midpoint of SQ, or QS, it doesn't matter. Same process. 4 plus 2 over 3, and 4 plus 7, whoops, not over 3, over 2, and 4 plus 7 over 2. Again, simplifying that, we get 6 over 2, and we get 11 over 2. And again, it's very easy to see that those two are the same. So both of our midpoints are at 3, 11 halves. And if you remember the definition of a bisector cuts a segment in half, so that means this segment and this segment are the same. That segment and that segment are the same, since that point in the center is the midpoint for both of them. So by definition, PR and SQ, the diagonals of that quadrilateral, bisect each other. Okay, here's your assignment for tonight, section 2.1. Remember that this assignment, since you're getting it on Friday, will be due right away on Monday, and you will be required to turn that in on Monday. And on Monday we will start section 2 too. All right, be good for the sub. And if you have questions and the sub can answer them, now is the time that you can work on some of those things.